Well, here's another example of using the quadratic formula where we have some a little bit more complicated terms there. But the quadratic formula still applies. We can still use it. So let's check it out in this case where we have a pi in here as the leading coefficient. There's a 2 pi as the middle term. And just to show you that you can use this for really anything that is the standard form quadratic equation. So if I'm going to plug this in, first let me identify my a, b's, and c's. A is equal to pi. B is equal to 2 pi. And c is equal to -2. And let's go ahead and plug this in. So x equals -b plus and minus the root of b squared minus 4ac all over 2a. There we go. And now the game is just to simplify correctly. So plug in correctly, use the correct formula to begin with, plug in correctly, then simplify correctly. So let me continue. I've got -2 pi plus or minus the root of 4 pi squared minus 4 times pi times -2 gives me overall a positive 8 pi. And all of this over 2 pi. Now notice something interesting under the root, the 4 pi squared plus 8 pi. Notice that I could factor out a 4 from those two terms, and a 4 is a perfect square. So this is going to be kind of nice. Let me do that, at least as far as simplifying goes. So this is -2 pi plus or minus the root of 4 times pi squared minus 2 pi in the parentheses. Okay, and I'll continue my root bar there, and then all of that over 2 pi. And I could have factored out a pi also, but if I factored out pi, since I could not factor out pi squared, it doesn't really give me something that I can root, so that's why I just left that in there. Now this thing I can actually break up as the root of 4 over the root of pi squared minus 2 pi. So let me continue that up here. This gives me -2 pi plus or minus the root of 4 times the root of pi squared. Oh, I don't know why I put a minus there. There's a plus. Let's come back to that. Plus 2 pi. All right, just wanted to subtract for some reason. I don't know, it's in my bones. Okay, all over 2 pi. Let us continue. The root of 4 is 2, so this comes out as -2 pi plus or minus 2 root pi squared plus 2 pi, and all of that is over 2 pi. Oh, I love this. Lots of pi going on here. And I noticed that there is a factor of 2 in both terms in the numerator that can be reduced by the denominator. So let me go ahead and separate this into 2 terms. So it's going to be -2 pi over 2 pi plus or minus 2 root pi squared plus 2 pi all over 2 pi. And -2 pi over 2 pi, that just comes out to -1 plus or minus. These 2's cancel, so that I'm just left with the fraction with the root on top, pi squared plus 2 pi, all over pi. Okay, and you can approximate from here. These are the exact solutions. Put a little squiggly around that. And I think I've actually calculated this. I have. So let me break this up into the 2 approximate solutions that you can check on your own time. But just to point out what I'm doing here, it's -1 plus case here. The root of pi squared plus 2 pi all of that over pi, and -1 minus the root of pi squared plus 2 pi, all of that over pi. The one on top comes out to approximately 0.279 to the thousandths place, so 0.279. And the one on the bottom comes out to approximately -2.279. 2.279. There we go. So see if you can crunch the numbers and get that in your calculating device. And again, just make sure that you're not estimating before you get your final result. One way you would accidentally get a different answer that might not work is if you use 3.14 for pi. 3.14 is an okay approximation. 3.14159 is a better approximation. And however many digits of pi your calculator can hold is an even better approximation. So try to use the pi button on your calculator, try to use the value of pi in Excel or wherever you're doing it, and put all of this into a single calculation, then round your answer at the end. So let me continue. I've got just one more example, at least so far, I might add to it later, of using the quadratic formula. So stay tuned for at least one more video.